This has been Youngblood and Wyatt M talking about the inverse of a function. We're going to talk about finding the inverse, the concept of domain and range, and the historic significance. So here we have the function f of x equals 3 minus 2x over x plus 5. First, our goal is to find the inverse. So first we're going to switch the x's and y, and we're going to solve for y in terms of x. So we have 3 minus 2y over y plus 5 equals x. Next, we're going to multiply both sides by y plus 5 so we can eliminate the denominator. And then we're going to distribute the x to the y and the 5. So we have 3 minus 2y equals x times y plus 5, and then we have 3 minus 2y equals xy plus 5x after we distribute the x.
Then we're going to subtract 3 from both sides, as well as subtracting xy from both sides. And then in order to get the left side positive, we're going to multiply by negative 1. This leaves us with 2y plus xy equals 3 minus 5x. Then we factor out the y from 2y plus xy, and we're left with y times 2 plus x equals 3 minus 5x. Then, now that we have a single y, we divide both sides by 2 plus x, and we're left with y equals 3 minus 5x over 2 plus x, which is our inverse function.
So here we have a function and its inverse. And the inverse of a function results in the domains and range being switched. So we have all our possible x values over here and our possible y values. The x represents the domain and the y represents the range. So if we have x value of 1 and y value of 4, in the inverse function our x value will become 4 and our y value will become 1. And the same with the rest of the values. This graph represents the idea that the domain and range are switched. So here in blue we have our original function f of x equals 3 minus 2x over x plus 5. And you can see here that our vertical asymptote for our original function is at x equals negative 5, while in our inverse function our horizontal asymptote is y equals negative 5. And you can see that these two are switched as well.
So what is the significance of inverse functions? Inverse functions are essential to solving equations because they allow mathematical operations to be reversed. The inverse of exponential functions, which are known as logarithms, are used to solve exponential equations. One such example of how you might use an inverse equation is when you're trying to go from Celsius to Fahrenheit or Fahrenheit to Celsius. The inverse function of a formula that converts Celsius and Fahrenheit is a formula that converts Fahrenheit to Celsius. And here is the formulas and its inverse.